Hello professionals, in this video I will be designing and elucidating on the electrical load estimate, also called electrical load schedule and sometimes called electrical load spreadsheet. Electrical load estimate has always been the focal point of every electrical design because it is from it we do determine our building connected load. For example, this project now is 210 kVA. So electrical load estimate requires empirical knowledge of the designer. But to begin with, electrical spreadsheet has always been most arduous sheet for most electrical engineers, probably because of how complicated most designers used to design their system. For example, here is an electrical spreadsheet. So before you'll be able to even understand the spreadsheet, talk less of understanding the line diagram is always very difficult. So here is a simple spreadsheet starting from the header section. So we're having a distribution reference code here, and what this implies is that the name of the distribution board we are designing. If you could remember, I explained that we do design electrical system in codes. For every distribution board we are trying to add into a design, we have to give it a code, Control V. So for example, now this one is distribution board A, while this one is distribution board B. So this is how the code goes. I named the distribution board C, distribution, etc. Even our main panel for the building, I named it main panel reference code. I named it BOFP. And you still need to specify the location. The reason for this is that most often, if a service is going to go through your project, you won't expect him to be going through the entire design phase. You would rather go directly to the load estimate. Here is it. So you need to specify the location. So for this one is at ground floor apartment A. I don't have the project there. So this one is for first floor apartment 2. So we have different apartment for this project. First floor apartment 3. Here is the power design. So this is our distribution board. So we'll name it distribution board A because we're having circuit A here. So CP. DB/A. So can increase the scale FC enter 1.5. So this is our distribution board A for the ground floor of this project. So if we were to have another distribution board for the first floor, so CP, copy. So where is the distribution board A? Project ought to have another board. So let's assume it's around here. And we've named this circuit B already, right? So we'll copy our board. CP. So this is our distribution board B. So for example, the sheet I designed for that project, so these are our distribution board A. Control F, Control V, right? So Control X, Control V. So distribution board A, the location is at the ground floor. Let's continue with it. So we specify the location. Likewise, we specify the feed panel, which is where is the main coming from. Is it coming from the electrical main, from the main house supply, or is it coming from another sub panel, or is it coming from another panel, so etc. So you specify the feed panel code. So the sub panel I'm having for this project is BOFP. So here is the feed panel code, and the final thing is the MCB ratings. So MCCB rating is the protective devices, but the only thing you need to understand for the MCCB rating is that the value here, Ctrl X, so we'll be able to syllogize it from the building total current amperage. On a norm, you won't be writing this first, so you can just hold on, not until you calculate for the distribution board. So, and it also means the size of the distribution board they will be using for such a project. On a norm, MCCB will be located at the power box for the building. So the power box is the box that is always situated beside the distribution board. So it is where the power main will first drop before going to the distribution board. So the size of the MCCB rating here will be the size of the circuit breaker we'll be using for the power box. So having gotten that, let's proceed to the table.